How to write a custom derived macro. Let's create a crate named hello macro that defines a trait named hello macro with one associated function named hello macro. Rather than making our crate users implement the hello macro trait for each of their types, we'll define a procedural macro so users can annotate their type with derive hello macro to get a default implementation of the hello macro function. The default implementation will print hello macro, my name is type name, where type name is the name of the type on which the trait has been defined. In other words, we'll write a crate that enables another programmer to write code like listing 19-30 using our crate. Import the hello macro, import the hello macro derived hello macro, and then this is what we want the user to be able to write. Okay. And if I'm correct, I believe one of these is the actual macro and one of these is the procedural macro. No, why are there two imports? I don't understand why there are two imports. Oh, no. The reason why there are two imports is because one is a trait. They just happen, the package name just happens to be hello macro. So this should probably be the macro and this should probably be the trait, if I'm guessing right. Yeah, the trait. Here we go. Cool. That makes sense. This code will print hello macro, my name is pancakes when we're done. The first step is to make a new library crate like this. Let me read through and I'll decide whether or not I want to do this example, because from right now, it doesn't seem like I'm going to be creating macros. This doesn't seem like something I should be doing. Cargo new hello macro lib to create a library. Got it. Next, we'll define the hello macro trait and its associated function. Source lib, public trait, hello macro. One function called hello macro. Got it. We have a trait and its function. At this point, our crate user could implement the trait to achieve the desired functionality like so. We could have the trait struct pancakes, and we can implement hello macro for pancakes, and then we can write the associated function. This is all pretty standard, and then we call pancakes hello macro. Yeah, we can definitely do that. However, they would need to write the implementation block for each type they wanted to use with hello macro, which personally I think that's fine, but okay. We want to spare them from having to do this work. Additionally, we can't yet provide the hello macro function with default implementation that will print the name of the type the trait is implemented on. Rust doesn't have reflection capabilities, so it can't look up the type's name at runtime. We need a macro to generate code at compile time. That's very informative. Rust does not have reflection capabilities, so it can't look up the name of the trait or look up the type's name at runtime. I was unaware of that. That seems very important. Okay. In order to do this, they have to implement or import another macro which will generate code at compile time to give us the type's name. The next step is to define the procedural macro. At the time of this writing, procedural macros need to be in their own crate. Eventually, this restriction might be lifted. The convention for structuring crates and macro crates is as follows. For a crate named foo, a custom derived procedural macro crate is called foo derive. Let's start a new crate called hello foo derive inside our macro project. Okay, so I was right. This is the procedural macro, and derive just happens to be part of the syntax that is mandatory for it. So we're just creating another lib here. Our two crates are tightly related, so we create the procedural macro crate within the directory of our hello macro crate. If we change the trait definition in hello macro, we'll have to change the implementation of the procedural macro in hello macro derive as well. The two crates will need to be published separately, and programmers using these crates will need to add both as dependencies and bring them both into scope. We could instead have the hello macro crate use hello macro derive as a dependency and re-export the procedural macro code. However, the way we structure the project makes it possible for programmers to use hello macro even if they don't want the derived functionality. Okay, pretty much what they're stating here is that we already know that the procedural macro has to be in its own crate. That is a given. So if we have our trait in one crate, a procedural macro definitely has to be in its own crate. That gives us two crates. The user at this point in time, if they want, they have to use both as dependencies, list both as dependencies in their package in order to use this and this. But they still have the option of just using this without using the derived procedural macro, because they may not want to. Another thing they did say we had the option of doing if we really wanted to is list the procedural macro as a dependency, import it as a dependency into the trait crate, and then re-export it there. So then the trait crate has both of them. But we could then force our users to use our procedural macro when they really don't want to, depending on how we implement it. We need to declare the hello macro derive crate as a procedural macro crate. We'll also need functionality from the syn and quote crates, as you'll see in a moment. So we need to add them as dependencies. Add the following to the cargo.toml file for hello macro derive. Okay, so just off the bat, this thing has its own dependencies that it depends on. That is a bad sign to me. I'm not writing any of these. And then lib proc macro true. That just looks like a flag. That's not a... Okay, understood. To start defining the procedural macro, place the code in listing 19-31 into your source/lib.rs file for the hello macro derive crate. Note that this code won't compile until we add a definition for the implement hello macro function. File name: hello macro derive /source/lib.rs. We have the extern crate proc macro, which we said it was true, so yeah, it exists. Create proc macro token stream, which we already noted. We take things input as a token stream and we output as our token stream. They told us that earlier. We have the two dependencies that we mentioned in our cargo.toml file. And then here we're defining the proc macro derive hello macro, so we're creating a procedural macro right now. And it says construct representation of Rust code as a syntax tree that we can manipulate. So we're using this package seemingly to parse the abstract syntax tree of Rust, build the trait implementation, and then we're using this, which might be a function that we haven't implemented yet, to actually do the stuff we wanted to do. And that just takes a reference to the AST, abstract syntax tree. Notice that we split the code into the hello macro derive function, which is responsible for parsing the token stream, and the implement hello macro function, which is responsible for transforming the syntax tree. This makes writing a procedural macro more convenient. The code in the outer function, hello macro derive in this case, will be the same for almost every procedural macro crate you'll see or create. The code you specify in the body of the inner function, implement hello macro, in this case, will be different depending on your procedural macro's purpose. So yeah, they're just stating how they broke it down into two different parts. This part is generic to everything because you're always going to need to parse the token stream. Yeah. And then here's where you do your implementation. So that's the logic, the business logic for what you're working on. Moving onward. We've introduced 3 new crates: proc macro, syn, and quote. the proc macro crate comes with Rust, so we didn't need to add that to the dependency in cargo.toml. The proc macro crate is the compiler's API that allows us to read and manipulate Rust code from our code. Okay, that's why it just marked as true. Got it? It said lib. The syn crate parses Rust code from a string into a data structure that we can perform operations on. The quote crate turns syn data structures back into Rust code. These crates make it much simpler to parse any sort of Rust code we might want to handle. Writing a full parser for Rust code is no simple task. So seemingly, the syn and quote work together just to translate Rust, parse it, and then return back data structures that are in Rust. So to break it down and then to build it back up in some way you can work with. The hello macro derive function will be called when a user of our library specifies derive hello macro on a type. This is possible because we've annotated the hello macro derive function here with proc macro derive and specified the name hello macro, which matches our trait name. This is the convention most procedural macros follow. Okay, so the name collision, the names being the same between the trait and the procedural macro, that's convention. That looked weird, but apparently that's the way it's done. The hello macro derive function first converts the input from a token stream to a data structure that we can then interpret and perform operations on. This is where syn comes into play. The parse function in syn takes a token stream and returns a derived input struct representing the parsed Rust code. Listing 19-32 follows the relevant parts of the derived input struct we get from parsing the struct pancake string. Okay, the derived input, snippet, identity, span, bytes, struct. So yeah, this is just the tokenization of it, seemingly. Of pancakes, plural. It has identity. I mean, maybe that's the type name. And we know that it's a struct. That's about it. Okay. The fields of this struct show that the Rust code we've parsed is a unit struct with the identity identifier, meaning the name of pancakes. The fields of this struct show that the Rust code we've parsed is a unit struct with the identifier, meaning the name of pancakes. There are more fields on this struct for describing all sorts of Rust code. Check the syn documentation for derived input for more information. So we know here it's a unit. I see. Here we know it's a struct, and here's the name of it, which is pancakes. And more information go to there, which is just looks like it's just the is it the cargo? Yeah, the crates.io documentation page. Coming back. Soon we'll define the implement hello macro function, which is where we'll build the new Rust code we want to include. But before we do, note that the output for our derived macro is also a token stream. The return token stream is added to the code that our crate users write. So when they compile their crate, they'll get the extra functionality that we provided in the modified token stream. Okay. They want us to note that the output of this procedural macro is a token stream, and that this token stream at compile time, when the user using this macro, attribute like macro, at compile time, this will expand and add functionality to whatever they attach this macro to. In our case, it's pancakes. You might have noticed that we're calling unwrap to cause the macro. You might have noticed that we're calling unwrap to cause the hello macro derive function to panic if the call to the syn parse function fails here. It's necessary for our procedural macro to panic on errors because proc macro derived functions must return token streams rather than result to conform to the procedural macro API. We've simplified this example by using unwrap. In production code, you should provide more specific error messages about what went wrong by using panic or expect. So here they're explaining, I can just go up for it, up. They're explaining this part. We used unwrap. And the reason why they use unwrap is if there is an error, it has to be reported because the API for the procedural macros is strictly token stream and output token stream. You can't do anything with results. However, they said in production code, you might want to change that out with more specific error messaging to let the user know what actually went wrong. Now that we have the code to turn the annotated Rust code from a token stream into a derived input instance, let's generate the code that implements the hello macro trait on the annotated type as shown in listing 19-33. File name hello macro derived, source lib. So here's this finally. We take the identifier, which we found right there, quote, using another macro, implement hello macro for name. I see, here's where we do the actual implementation. So we're writing the associated function for it. And then gen.into, I guess this is generate the code into the user space. We get an indent struct instance containing the name identifier of the annotated type using ast.indent. Oh, I keep saying indent, ident. The struct in listing 19-32 shows that when we run the implement hello macro function on the code in listing 19-30, the ident we get will have the ident field with a value of pancakes. Thus, the name variable in listing 19-33 will contain the ident struct instance that we print will be a string pancakes, the name of the struct in listing 19-30. So more or less, they're just saying this thing is going to be pancakes. And we know that because we saw the derived output of what that looks like earlier, which was here. The quote macro lets us define the Rust code that we want to return. The compiler expects something different to the direct result of the quote macro execution, so we need to convert it to a token stream. We do this by calling the into method, which consumes the intermediate representation and returns a value of the required token stream type. Where is the into? Into. Okay, this is what returns the token stream. So I thought it was just like inputting it directly onto the struct, but apparently that's making sure that the output is the expected type, a token stream. The quote macro also provides some very cool templating mechanics. We can enter hashtag name and quote will replace it with the value in the variable name. You can even do some repetition similar to the way regular macros work. Check out the quote crates documentation for a thorough introduction. Okay, they're just pointing out that they have some cool templating things, the quote package, crate, and this is one of them, an example. This maps to name, and if you want to know more, you need to go to the documentation. We want our procedural macro to generate an implementation for our hello macro trait for the type the user annotated, which we can get by using hashtag name. The trait implementation has one function, hello macro, whose body contains the functionality we want to provide, printing hello macro, my name is, and then the name of the annotated type. The stringify macro used here is built into Rust. It takes a Rust expression, such as 1 plus 2, and at compile time turns the expression into a string literal, such as 1 plus 2. This is different than format or printline macros, which evaluate the expression and then return the result into a string. There is a possibility that the hashtag name input might be an expression to print literally. So we use stringify. Using stringify also saves an allocation by converting hashtag name into a string literal at compile time. And I just want to see exactly where they use it. Here we go. I see. They're using stringify because there's a possibility that that name is something weird that could be evaluated, but you don't want to evaluate it. Okay, cool. And that's built into Rust, so they didn't have to import it. And yeah, cool. At this point, cargo build should complete successfully in both hello macro and hello macro derive. Let's hook up these crates to the code enlisting 19-30 to see the procedural macro in action. Create a new binary project in your project's directory using cargo new pancakes. We need to add hello macro and hello macro derived as dependencies in the pancakes crate cargo.toml. If you're publishing your version of hello macro and hello macro derived to crate.io, they would be regular dependencies. If not, you can specify them as path dependencies as follows. And then this is for the pancakes cargo.toml file. And this is the pathway of defining your dependencies. Put the code in listing 19-30 into source/main and run cargo run. It should print hello macro, my name is pancakes. The implementation of the hello macro trait from the procedural macro was included without the pancakes crate needing to implement it. The derived hello macro added the trait implementation. That is the end of procedural macros, and that was a lot of stuff there. This is not something I should be writing myself. I don't feel comfortable writing this, and I'm not going to do this example with the code editor thing on the side, because if I do something wrong, I'm not going to even know what's going on. Now let's explore how the other kinds of procedural macros differ from custom derived macros. One last one, and this one must be short. Attribute-like macros. Attribute-like macros are similar to custom-derived macros, but instead of generating code for the derived attribute, they allow you to create new attributes. They're also more flexible. Derive only works for structs and enums. Attributes can be applied to other items as well, such as functions. Here's an example of using an attribute-like macro. Say you have an attribute named route that annotates functions when using a web application framework. Route get. So I have seen that briefly. That makes sense. You're defining your get. This route attribute would be defined by the framework as a procedural macro. The signature of the macro definition function will look like this. Proc macro, route, takes in a stream, outputs a stream. Well, the item is a stream, so this thing. Oh, here's the attribute. So this is the attribute. This is the item. I see. And then it outputs a stream. So it's not too different from the thing above. Here we have two parameters of the type token stream. The first is for the content of the attribute, the get, and then comma slash, the slash part. The second part is the body of the item the attribute is attached to. In this case, the function, index, and the rest of the function's body. Oh, so they're saying that this part is just one attribute. And then this part is the actual function. So it kind of works like a decorator. Okay. Other than that, attribute-like macros work the same way as custom-derived macros. You create a crate with the proc macro, create type, and implement a function that generates the code you want. Okay, so the rest of it's just the same. Just the way it's initially written is different, and you kind of think of it as like a decorator. Function-like macros. Function-like macros define macros that look like function calls. Similarly to macro rules macros, they're more flexible than functions. For example, they can take an unknown number of arguments. However, Macro rules macros can be defined only using the match-like syntax we discussed in the section Declarative Macros with Macro Rules for General Metaprogramming earlier. Function-like macros take a token stream parameter, and their definition manipulates that token stream using Rust code as the other two types of procedural macros do. An example of a function-like macro is a SQL macro that might be called like so. Okay, so a few things here. One, these function-like macros look like functions. They are similar to the macro rules in that they're more flexible than functions. Example is that you can have an unknown amount of arguments. That's pretty cool. In terms of definition, how they declared, it's the match-like syntax where you have the arm and you have the expression that we read pretty recently in the declarative macros with macro rules for general metaprogramming. And here's an example of a SQL one where you have the select statement within here. This macro would parse the SQL statement inside it and check that it's syntactically correct, which is much more complex processing than a macro rules macro can do. The SQL macro would be defined like this. So the definition is more or less the same. Procmac, public function SQL, input token stream, output token stream. I'm guessing the rest is just the same as the matching pattern, which might be annoying. I wouldn't want to write a pattern to match generic SQL. Moving onward. This definition is similar to the custom-derived macro signature. We receive the tokens that are inside the parentheses and return the code we want to generate. Yep. Summary. Woo. Now you have some Rust features in your toolbox that you won't use often, but you know they're available in very particular circumstances. We've introduced several complex topics so that when you encounter them in error message suggestions or in other people's code, you'll be able to recognize these concepts and syntax. Use this chapter as a reference to guide you to solutions. Next, we'll put everything we've discussed throughout the book into practice and do one more project. So yeah, I completely agree with this summary. This is good knowledge to know just as a reference, but I won't actively use this unless I really, really need to, if it's like mandatory. And if I do see this somebody else's code or someplace somewhere, I'll be able to recognize it. I mean, that's the important part. Knowledge is power. Yeah, but with that, that's the end of the video. Hope you liked it. If you like it, hit like, subscribe. Outside of that, one more project. Peace.